Okay, let's take a look at number 3 from the midterm. In this question, you've been asked to look at the acid-catalyzed hydrolysis of benzyl benzoate. Here is the benzyl group, and here is the benzoate group. Under acidic conditions, so we have water, we have acid, and we have our substrate. So, again, the first thing we like to do under acidic conditions is protonate something. Yes, the most likely site of protonation, I suppose, is the H3O+, but remember, that's how the acid exists in an aqueous medium anyhow. H3O+ is probably the proton carrier. So we're going to protonate one of the oxygens in our ester. We discussed in class that this is actually a more basic site than this particular oxygen, so we're going to protonate the carbonyl oxygen in this case. When we protonate the carbonyl oxygen, we have activated our carbonyl compound. Notice now I even asked you in the question to replace drawing the 6-membered benzene with pH to indicate a phenyl ring. This is just because it's easier rather than drawing those ring structures out. Now, we still have our water around, and what's the next thing that's going to happen? Well, we've protonated the carbonyl oxygen, which means that we've now activated the carbonyl carbon towards attack by a nucleophile, and we have a nucleophile in the form of water. These are all under equilibrium conditions. Oops. So now we realize that the one thing that can happen is this can just go back by losing the elements of water. Another thing that can happen is something can come along and remove a proton. And we're going to skip a step in this instance because we're going to have something come along and remove that proton, and then it's going to place the proton somewhere else in the molecule. So we're going to have a minus H plus followed by a plus H plus. We have two reactions that are occurring here. And I'm just going to move a proton from here to the oxygen that's attached to our alkyl group. And the reason we did that is we now have a good leaving group that's not water. If we moved our proton up to here, we would just be removing water. We'd actually be going back this way. Now we can remove, and I'm going to push it off with the lone pair of electrons on one of the other remaining oxygens. So here's one of our products. Now all we have to do is something will come along and remove this proton. Let's do it specifically. We have lots of water around, we have other substrates around, we have lots of things around that can remove that final proton. And that gives us our carboxylic acid product, regenerates our catalyst. So we have carboxylic acid as one product and the benzyl alcohol as the other. There we go.